The last two rules that we are going to learn is the product rule and the quotient rule. And these are not difficult rules, but you will have to memorize them, and they're a little bit more intense than the power rule and the other basic rules we learned in the previous videos. So what happens when you have two differentiable functions? And I want to make sure that I explain the word differentiable. Sometimes students struggle with that. Differentiable simply means that you are able to take the derivative. So that's what differentiable means. You can take the derivative. So you have two functions, u and v, and they both have derivatives. What if they're multiplied times each other? There is a common misconception that students think, well, if you're just multiplying them, then, why don't you just multiply the derivative of u times the derivative of v? And that's not okay. It doesn't work. I have a proof of the following rule, but I will provide that for you at a later time. For now, I just need you to understand that you cannot take the derivative of one function and multiply it by the derivative of another. Instead, what you're going to do is you're going to take the first function and copy it as it is. You are then going to multiply that times the derivative of the second function, and then add the second function as it is times the derivative of the first. So it's, in this case, uv prime plus vu prime. Okay? If those functions were called f and g, which is more common, it would just be the first times the derivative of the second plus the second times the derivative of the first. Okay? And because it is plus, the order doesn't actually really matter as long as you have one of the functions times the derivative of the other plus the other function times the derivative of the other function. And so I kind of wrote it out here so that you can read it and say it to yourself, because you are going to have to memorize this rule. The derivative of the product of two functions is first times derivative of second plus second times derivative of first. And I have two examples here that I'm going to work out to see if you can better understand this rule. So the first thing I'm going to do is set up my information to the best of my ability. So I have a function times a function. So this is your u and this is your v. And what I'm going to do is just a quick setup here. I'm going to say u is going to be 5x squared. And then I'm going to say u prime, the derivative of u, would be 10x using the power rule. So the power rule doesn't go away. It still exists. It's actually helping us complete this product rule. Now I'm going to have v. Maybe I should use a different color for v. Let me see. I'll use green. So let's say I have v. And v is going to be 2x plus 1. And then v prime then would be 2. So this is my setup. And all that needs to happen now is I need to multiply the u and the v prime and then add the v and the u prime. I think I said that right. u v prime plus v u prime. I call this the butterfly method. Change my color here. So I call this the butterfly method. I multiply these two together. So that's good. And again, it's multiplication, so it doesn't matter. 2 times 5x squared is going to be 10x squared plus, this is why it's the butterfly method, 10x. Now, I have a binomial here, so it's important that I have parentheses so that 10x multiplies by the 2x and the 1. Now, this is a correct derivative. At this point, you could stop if it's a free response, but if it's multiple choice, they're going to probably simplify a little bit more. So they're going to distribute that 10x and get 20x squared plus 10x. Combining like terms would give us the derivative is 30x squared plus 10x. Again, I normally do not have you multiply it out that far or simplify that far, but if it's multiple choice, it's more than likely they are going to simplify it in the choices, so you kind of have to go there. Okay, so let's look at now. You're probably thinking this, which is a good thing. Why did she do that? Couldn't she have just distributed that 5x squared into everything so that you don't have a product? Absolutely, I could have. I could have done 10x to the third power plus 5x squared. Okay, that's not a derivative, that's just the original. And then I could have taken the derivative with the power rule, and then I could have gotten to the same place that I used with this product rule. So absolutely, you could most definitely do that. But I'm teaching you the product rule right now with things that are real easy, and I honestly don't care which method you use. You can distribute and use a power rule, or you can use the product rule, which is a little bit longer. I actually would have probably distributed, but later on we're going to see things like this. We're going to see y equals 5x squared times cosine of x. Later on, don't be scared. And this, there's no distributing. It's a product of 5x squared times cosine of x, so we're going to need to use product rule, and there's no way around it. So right now we're just kind of doing the easy ones, and yes, you could just distribute and avoid the product rule altogether, but eventually you're going to have to know the product rule for functions like this. So that's just a heads up. Now if you look at our second example as I erase this, it's a binomial times a binomial. So again, could you just distribute, FOIL this out, and then take the derivative the easy way? Absolutely, and I would not be upset about that in any way. But I'm going to show you how the product rule would work, and you be the judge of which is the easier method. This is your u times your v, or your first times your second. And I like to set up my information first. So I put my 3x squared as my u, and then I do u prime, and that would give us 6x. The 4 goes to 0, it's a constant. And then I would do v, and v is 2x minus 1, and v prime would be 2. And then we're just going to work the butterfly method to get the derivative. We'll multiply u times v prime. Remember that 2 has to multiply by everything, that binomial, so make sure you use parentheses. And then we're going to add plus the second term times the derivative of the first, so that's our other wing there. Again, that 6x has to multiply by everything in by that 2x minus 1, so I've got to use parentheses. This is a very good answer if it's free response, but if it is not, if it's multiple choice, you will probably see a little more simplifying, and I'll do that by pausing the video and coming right back. Okay, so here's my final answer. I just distributed combined like terms. Now, if you had FOILed this out and done the power rule, would you have gotten the same answer? Yes. Would it have been less work? Probably. So is the product rule really helpful right now? Not really. You could FOIL or distribute and get away with not using the product rule at all. But in the future, you're going to have to work with things like this, which there's no way around it. So this is your first introduction. And even before we get to those cosine, those trig functions, you're going to work with tables, and you'll see that at my return, where the product rule, you have to know first times derivative of second plus second times derivative of first. All right, so that's the product rule. Let's go on and do the quotient rule. So quotient meaning the division of two functions. Again, you are not allowed to simply take the derivative of the top over the derivative of the bottom. So you are not allowed to just do u prime over v prime. That's bad. And I know that somebody's going to do it. Every year somebody does it, but don't let that person be you. So what's the formula then? There's a special formula. When you have a quotient that you cannot fix, in the previous video we talked about fixing quotients, then you have to follow this formula. And it's the bottom function times the derivative of the top minus the top function. It's very important, it's a minus the top function times the derivative of the bottom, all divided by the bottom function squared. The bottom's not prime, it's just squared. If you change the name of those functions to f and g, it's the bottom, and you have to start with the bottom because of the minus, the order matters. The bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Now, if I were to switch this f and g, then that would switch where I would place those. So instead of trying to memorize u's and v's, try to memorize the location. the derivative of a quotient of two functions is the bottom times the derivative of the top. Okay, so that's like one piece. Minus the top times the derivative of the bottom. That's another piece. All divided by the bottom squared. Okay, and I have one example here that I'm going to run through, and everything else works pretty much the same. The only way to make this harder is to essentially give you more complicated functions in the numerator or denominator. But this is a pretty basic quotient. I cannot undo this quotient. I'm dividing a monomial by a binomial. If it were flipped, then I could separate it into two different fractions, and I could avoid this quotient rule altogether. But it's not possible to separate this into two fractions because of the plus sign. So I will do my setup. My u is the top function, which is 3x. My u prime is 3. My v is 4x squared, that's the bottom function, plus 1. And v prime, of course, is 8x. Now, it's very important that you get the order right. When you're doing the derivative, you have to start with this wing. You cannot, it's still the butterfly method, but you can't, the order matters. You have to start with the v times u prime first. So I'll start with that wing first, and I'll say, well, it's 3 times this binomial, and as long as you're multiplying the 3 times everything, it doesn't actually matter what goes first, the 3 or the 4x squared plus 1. But usually we put the constant first. Okay, and then we're going to do minus, because the formula says minus. See right here. Minus the other wing. So it's the, let me do that again in blue. So it's going to be minus the other wing right here. So it's the bottom times the derivative of the top minus the top, which is 3x, times the derivative of the bottom, 8x. And don't forget, this is another mistake students make, you must divide by the bottom squared. Now the bottom is a binomial. So when you square that, you got to FOIL. You can't just square the first and the second. You actually got to FOIL it out. I'm going to press pause, and I'm going to go ahead and distribute and show you my algebra in just a moment. You can pause the video and work out this problem to simplify it. And I want to remind you, this is a good enough answer for me, but if it's multiple choice, you're going to see this simplified further. Now, this answer here is just distributing the top and then combining, well, there really wasn't any like terms to combine, but just kind of making it look pretty. This is a perfectly good answer for me. But on the assignment that you're going to work on, since it's multiple choice, they're going to go a step further and they're going to FOIL out this denominator. So I'm going to go ahead and pause my video and do that just to show you how that would look. So when you're foiling this binomial here at the bottom, you have to write it twice and FOIL it out, or if you know the shortcut, you can do that too. But remember, it's not just the first term squared and the second term squared. You actually have to FOIL it out. And this is what I get. There's no cancellations and there's no real reason why we needed to do that. Like I said, the thing I boxed in here in red would have been perfectly good, but on your assignment, they are going to simplify, and those are just the choices that were available. So just be aware of that. So to end the session, I want you to go ahead and write a summary and think about what are the most important rules, what are the most important things to remember. Don't forget, basically, don't forget this, don't forget that, to be successful with the rules that you've learned. And so you will have an assignment, and I hope this really helps. See you soon.